Hello, SE examination 2074. We're solving questions from science, group D. Let's do question number 22. Draw a diagram of laboratory preparation of ammonia gas and label the lime tower and gas jar. Also write the balanced chemical equation involved with this process. So this particular question here asks us to draw a diagram of laboratory preparation. So that's going to be the most difficult part of this question here. um, Fortunately, I don't have to draw all the diagrams from scratch. That's fortunate for me. But what you need to do is read a lot from the books. They are like few laboratory preparations that you have to prepare, and make sure you read a lot from the book and try to remember as many details as you can for these particular types of question. Before moving on to the actual diagram itself and labeling, let's talk about the chemical equation involved in this process. So any chemical equation, it requires two things: reactants and products, separated by this arrow over here. It shows which side is the reactant and which side is the product. Okay, so the reactant for this preparation is ammonium chloride and calcium hydroxide, the reactants, and the products for this reaction is calcium chloride, water, and ammonia gas. Right? So any chemical equation must always be balanced. That is, you'd start with the equation that does not have any coefficients like this. So that is unbalanced equation here. If you check on this unbalanced equation, you'll see that there's only one chlorine atom on the reactant side, but two chlorine atoms on the product side. So this is an unbalanced chemical equation. So to balance this, what you do is like start with adding the coefficients here. So if you add 2 here, there's going to be two chlorine atoms here and two chlorines on the product side as well, so that's good. There will be two nitrogen atoms here. Let's add 2 here so that there will be two nitrogen atoms here. We compare hydrogen and oxygen only at the end. We try to balance other elements first. First calcium, one calcium, that's perfect. Let's check for oxygen first, and then we'll move on to hydrogen at the end. There are two oxygen here, O2. There are two oxygen and one oxygen if it was not balanced. So adding 2 here makes 2 oxygen at the reactant side and 2 oxygen at the reactant side and 2 oxygen on the product side. So that's good. Let's check for hydrogen now. 6 hydrogen here and 4 hydrogen here. That makes 10 hydrogen on the reactant on the product side, and 2 here and 8 here. That makes 10 hydrogen on the reactant side as well. So that's perfect. So just adding 2 2 2 at these places makes this a balanced chemical equation. Okay, moving on the diagram here. So this is the beaker we start with. We place ammonium chloride and calcium hydroxide on this beaker. Let's call it the reaction beaker. Okay, the reactants are placed here in appropriate amounts. Heat should be given to initiate the reaction here. Without heat, this reaction cannot occur. Calcium chloride and water, they remain on the beaker itself because they cannot go anywhere. They are solid and liquid, so they remain in the beaker. Ammonia, it's a gas, so it moves away from the beaker, travels. Okay, and you have to have a lime tower here. This whole thing, it's a lime tower, and then ammonia gas is finally collected from downward displacement of air in this beaker over here. All right, to appropriately label the lime tower is here, and the gas jar, the jar that's used to collect the ammonia gas, is over here. All All right. So this is it. The most difficult part would be to remember as much details as you can for the uh, preparation diagrams. All right. So good luck and thank you.